Okay, so we're going to start section 2.7. Section 2.7. And this section is on interval notation. First, let's go ahead and review the inequality symbols or inequality signs. So we have greater than, greater than or equal to, less than or equal to. For example, we can use these to evaluate. Say we have -12, and then we're going to insert the right inequality symbol or sign, and then -3, -4 compared to -10, and -2 compared to +4. Remember that on the number line, numbers to the left of 0 are negative, and numbers to the right of 0 are positive, and numbers get smaller as they move farther and farther away from 0 to the left, and they get larger as they move farther away from 0 towards the right. So -2 is smaller than -3, right? And you can also write -12. -12 is smaller than is less than -3, but also what would be a true statement here would be to say -12 is less than or equal to -3, because as long as one of those two statements is true, the inequality is true. So you can also write -12 is less than or equal to -3, and that would still be true. So it's strictly less than, right? And it's also less than or equal to -3. -4, so you can write here, like I said, this would be true. What would also be true is less than or equal to -3, right? And -4 is greater than, right? It's greater than -10. And you can also write that -4 is greater than or equal to -10. And -2 is greater than, -2 is less than 4, because negative is smaller than a positive number always. So -2 is less than +4, and also true statement, -2 is less than or equal to 4. So again, this inequality, the less than or equal to, or greater than or equal to, or less than or equal to, sometimes confuses students, but as long as one of the statements is true, the inequality itself becomes true. So -12 we know is strictly less than -3, right? But we can also say that -12 is less than or equal to -3, because one of those statements is true. All right? So I wanted to go over these before we start working the problems in the workbook. So this is not in the workbook. This is an explanation I wanted to provide in addition to what's in the workbook. So now we're going to work problems from the workbook. And so we're going to go to 2.7, and let's consider, suppose you're given this graph. So you're given this graph, and this is example 5B in the workbook. Okay? So you're given this graph. You have a graph that looks like something like this, and it has the bracket here. It's closed parentheses, right, at -3.1, at -3.2, and it is shaded towards the left, right, towards the left, and it has a closed parentheses. That means, you see this bracket, so it's closed. Whenever you see the closed parentheses, it means that you are including the number. So negative 3.2 is included. If it's open parentheses, that means that it's excluded. So this one includes negative 3.2, right? So we need to write the inequality that corresponds to this graph. So because the inequality, the graphs is shaded towards the left, that means that you can use x or any variable, but I think the homework uses x, so you can write x is less than, right, or equal to, because it is closed, you have to write the equal here, negative 3.2. So this is the inequality for the graph. So the inequality for the graph is x is less than or equal to negative 3.2. Okay, so that's example 5b. What about example 5c? So example 5c has a graph that looks like this. It has the open parentheses. Oh, so now it's open. That means that the number is excluded. So negative 2.3 will not be included. So this one excludes the negative 2/3, right? In this case, we have negative 2/3. So this will not include negative 2/3. And it is also shaded towards the left. So notice it's shaded towards the left. So the inequality here is less than, but we're not going to write less than or equal to because it has the open parentheses. So it's x is less than, just less than, negative 2/3. So it will not include it, right? This is the inequality. So remember, if it's closed, it includes. If the parentheses is closed, it's included. If it's open, is excluded. So that is example 5c. Now, so we first, in these two examples, the graph is given to us and we need to find the inequality, right? So the graph is given and we have to find the inequality. Now we're going to switch things around. Now we're going to be given the inequality and then we need to find the graph for it. So let's now consider example 6. And so the inequality that they're giving us is negative 3 less than x less than or equal to 7. So you write, the number line will look like, and in the homework, you're going to be given the graph, so you don't have to draw them yourself, but you need to be able to identify them. So negative 3 will be somewhere on the left, 0 will be in the middle, right? And then 7 will be somewhere to the right of 0. And at negative 3, notice that the inequality sign does not have the equal to, so that's going to be open because it means that it does not include negative 3, right? And then at 7, it has a equal sign, so it's going to be included. And because x is between the two numbers, these inequality signs are going to be facing each other. One will be open, one will be closed. And then you're going to be shading in the middle of the two inequality of the two parentheses, of the open parentheses and the closed parentheses, because x is between negative 3 and 7, right? So the graph will look like that. Remember, you're shading between, and so at negative 3 the parentheses is open, and at 7 the parentheses is closed. Exclusion for open parentheses, inclusion for closed parentheses. Okay, now we're gonna introduce 3 types of notation. We're gonna introduce interval notation, and we're gonna introduce, actually for your homework I checked, you don't need to know about set builder notation, so I'm just gonna introduce interval notation, and then we're going to graph also. So we're gonna write the instructions. Let's consider example 10, and I will explain. So example 10, we're given x, so we are given the inequality x is less than or equal to negative 4.5. Okay. And then they want us to write this in interval notation. But to do that, I am first going to create the graph for it. So I'm going to graph this one first. Okay. And I know negative 4.5 is going to be to the left, right? Negative 4.5. And it says is less than or equal to negative 4.5. Okay. So because it has the equal sign, it's going to be less. So it's going to be closed, right? And it's going to be facing to the left because it's less than. So it's going to be shaded going toward the left, right? So at negative 4.5, you have a closed parentheses, but then you're going to be shading towards the left because x is less than or equal to negative 4.5. So this is the graph, right? Now in interval notation, once you have the graph, it's very easy to write it, the inequality in interval notation, because you follow the graph. One thing I need to explain is that as numbers get increasingly small, and I know that sounds counterintuitive, as numbers get smaller and smaller and smaller, they are moving towards negative infinity. Negative infinity is a concept that just means that numbers are getting smaller without bound, without end, but they're getting smaller. Similarly, they can get larger as they move to the right of 0, and they increase without bound towards infinity. Okay, so in interval notation, you write from negative infinity, right, and you're going to write an open parentheses here, comma, all the way to negative 4.5, right, and then you close the parentheses. Notice that this is exactly what the graph looks like, right? Coming from the left. Make sure you read these graphs. Make sure you read these graphs from left to right. You read them from left to right. So from negative infinity, comma, to negative 4.5, close parentheses at negative 4.5 because you are including negative 4.5, open parentheses at negative infinity because negative infinity does not have a bound, at least for this course. There's something called the extended real number system where we close negative infinity and positive infinity, but that's for to do proofs, but that's not what we're doing in this course. So right now we're just gonna, when we speak about negative infinity and positive infinity, they will always be open, meaning they're unbounded, right? So this is interval notation. Okay, so that's interval notation. And so we have, that's example 10. All right, so let me do one more like this, where we are going to graph it and then you're going to write it in interval notation. So we have, let's take a look at example 12. Okay, example 12. We have negative 3 is less than a, and that's less than, a is less than 2. So we're going to graph it first. And remember that we have negative infinity, positive infinity, negative 3, and 2. And you don't see equals, right? Equal sign here on the inequality signs. They just, there's less than, less than. So a is between the two. So it's gonna be open parentheses at negative 3 and open parentheses at 2. And they're gonna be facing each other because a is between these two numbers. And you're gonna shade right in the middle, right? So this is the graph. And interval notation is exactly what you're looking at. You're gonna start at negative 3, comma, 2, and you're gonna put open parentheses around the numbers. So this is interval notation. Okay, interval notation. So that's example 12. Now let's consider one more, example 14. And so we have x is less than negative 5 or x is greater than negative 2. Okay, so basically here you have two cases, right? So I'm going to draw the I'm going to draw the graph for it. Find the numbers -5 and then 2, -2. So -5 and -2. So -5 and then -2 somewhere there. It says x is less than -5, so it's going to be open, right, because it's less, and then towards the left. So I'm going to shade towards the left because x is less than -5, and then or x is greater than -2, so it's going to be facing to the right because it's greater, and it will still be open. So shade all this area here, right? And so that's the graph. Now how do we write this in interval notation? Follow the graph, -infinity, comma, -5, open right at both. You're gonna use something called a union symbol to unite the two intervals. It's called the union symbol. Sometimes MATH Plus, instead of the union, uses comma between the two intervals. So try to use the union symbol if you find it there in the symbols given to you when you do the homework, or try to put comma. So I'll show you both ways, right? But let me finish this one. So union and then parentheses, -2, comma, infinity, parentheses. So this is interval notation. This is one way to write it. This union symbol should show up there in the list of symbols. Another way to write it I have seen is -infinity, comma, -5, and then close, make sure the parentheses are included, comma, and then -2, comma, infinity, like this. I have seen this way of writing it too. So check MATH Plus to see what is acceptable there. Okay. All right. So this is section 2.7. Section 2.7. So I've done a variety of problems here that are going to help you with the homework questions. So when you're watching these videos, you may want to pause, go back, and watch again, right? Because especially if something doesn't make make sense, you want to watch a second time. Okay, so now we're gonna go to section 3.1 and 3.2 in the workbook, and this is graphing linear equations in two variables. So section 3.1 and 3.2, they come together, these two sections. So I'm gonna get another marker because this one is fading. Give me a second. Okay, so section 3.1, let's go ahead and do example 2. In example 2, we are given, so make sure you're looking at example 2. I'm gonna show you on the screen here. This is the graph I'm looking at, and I'm going to be identifying the points, like for example point A, point B, point C, D, E, F, G, H. And how do we read a point? Well, first of all, let me remind you how to read. So for example, any order pair is read starting from the origin, the point 0, 0. For example, point A, notice that we are going to be identifying point A, right? So from the origin, point A, you first move. The first element of an order pair represents the X. The second element represents the Y. This is the X-axis, that is the Y-axis, okay? So here, using this graph, notice that point A, from the origin, it moves 2 places to the right. So that's why this is, the X value is 2. And then from there, it moves 1, 2, 3, 4, 5, 6 places up. So that's the Y, right? So once again, for example, point A is identified as 2, 6. Why is that so? Because, let me write this. Because, okay, so this is your Y-axis, and this is the X-axis, right? And so A, you always start at the origin, point 0, 0. A, notice that is found when you look at this graph, right? A is found where I start here at 0, 0, so it's found 1, 2, 2 to the right, and then 1, 2, 3, 4, 5, 6 up. So that is why this point is the point, this is the point 2 comma 6, the point A. Okay, similarly you're going to identify all the other points. So point B, notice point B is 1 2 3 4 to the left, so that's -4, and 1 2 3 up 3. So then you have -4 comma 3, and I'm gonna give you the other values so you can practice. -3 comma -2 for C, and D is 0 comma -2. E is 5 comma 0. F is -3 comma 0. G is 2 comma -4, and the last one, H, is 4 comma -5. Okay, remember, you first find the X, right? So, and then the first element is always the X, the second element is the Y. X moves here, this is the X-axis, it moves from left to right, and the Y, they move up and down, okay, on the coordinate plane. So that's example number 2. Okay, now example number 2 is, I'm gonna move on to the next example. I'm gonna consider example number 3. So example number 3, it says identify the intercepts and graph the equation. So we want to identify the intercepts and graph the equations. Okay, first of all, let me give you okay, so let me write the equation. So we have x plus y is equal to 5. Okay, so whenever you're trying to graph a linear equation, you have to remember that linear equations are just lines, right? And so when you graph them, you really just need 2 points to graph them, 2 different points. And then, you know, you extend, that will give you a line segment, and then from there you can just extend, right? And then get a good idea of what the graph is going to look like. So this is a linear equation, x plus y equals 5. The intercepts, we're talking about the x and the y intercepts. These are 2 points on the line that are gonna help us find the graph of this line, right? So how do you find the x-intercept? The x-intercept, you find it by letting y, so remember you have x and y, right? So this is an ordered pair here. So how do you find the x-intercept? You let the y be equal to 0, so I'm going to write 0 there. And then you solve for the x. So you have x plus y is equal to 5. If y is equal to 0, I'm going to write 0. X plus 0 equals 5. And then just find the x value. So x plus 0, that's just x. It's going to be 5. So then you have the first point. You see, you get the point 5 comma 0. So you're going to plot that. Five comma 0, so you find 5 first, because remember that's the x here. 1 2 3 4 5, so x is 5, and then y is 0, so it stays right here. There's the first point, this one, 5 comma 0. Okay, now we're gonna find the y-intercept. The y-intercept is found exactly the same way, except now x is 0, so I'm gonna write 0 here for the x, and I'm gonna look for the y value. I use the same equation, x plus y equals 5. You let the x be equal to 0, and you write 0 plus y equals 5, right? And so that means that 0 plus y, that's just y, is equal to 5, and you get the point 0 comma 5. So then 0 comma 5, that means that x is 0, right? And then up 5, 1 2 3 4 5. Here's 0 comma 5. You connect the 2 points, and you see you can then graph this line. There's the graph of it. This is the graph of this equation here. So you get the graph of the equation. I'm lowering the paper because I know that sometimes, there it is. So this is the graph that we get by finding the x-intercept and the y-intercept, right, you get those 2 points that you need, 5, 0, 0, 5, and then you extend the line segment to get the graph of this line. This is the line x plus y equals 5, right? And so the easiest way to graph a line, you find 2 points, and the way to find the 2 point, and the easiest, I think the easiest 2 points to find are the x and the y-intercept. Is that all? Or can I find different points? You can find different points. For example, say you don't want to, let's just say you don't want to use the x and the y-intercepts, right? Can you find other points? Of course. You can. I'm going to show you, and you should get the same line, right? But let me just show you how, because I think there's an example in the homework where you need to find different points. So you have, let's say you have the equation x plus y equals 5, and you want to find different points. So you can create a table, x here, right? You select your x, and then you need to find your y here, okay? So what is, if x is, what is y? So if x is 1, what is y? How would you find y here? Well, you have the equation x plus y equals 5. You need to replace x with 1. So you write 1 plus y equals 5. And then you need to solve for y. So you need to isolate the y here. So you're going to subtract 1 from both sides, right? And so that gets rid of the 1 here. You bring down the y, and y is equal to 5 minus 1, which is 4. So then if x is 1, y is equal to 4. You see how you can get, and then you get the point. So which point are you getting? X, y, you get the point 1, 4. All right, so let's do one more. So what about if x is, let's say, 2? Well, same thing. You're going to use x plus y equals 5, same equation, but now replace the x with 2. 2 plus y equals 5. You're solving for y now, so you're going to subtract 2 from both sides and bring down the y. 5 minus 2 equals 3. So if x is 2, y is equal to 3, right? And then you get the point 2, 3. So now you can plot these 2 points and graph the line, and you're going to get the same graph you got previously, but using different points, okay? So I wanted to show you a different way of doing this, but you should be able to find the x-intercepts and the y-intercepts. So if the problem is asking for the x-intercept or the y-intercept, just find the x-intercept and the y-intercept. So follow the instructions, okay? All right, so let me drink some water. So you know how to find the x and the y-intercept. Let me do one more example finding the x and the y-intercept. So let's do example 4. We're given equation 3x plus 2y equal to 6. And so we need to find the x-intercept and the y-intercept, and then graph the equation. Graph the line. Okay, so x-intercept, remember, we are going to replace the y with 0 and find the x. So, okay, 3x plus 2y equals 6. That's 3x plus 2 times 0, right, equals 6. Now 2 times 0, that's just 0. So it's 3x plus 0 equals 6, which just gives us 3x. And then we're going to divide by 3, right? That gets rid of the 3, and so x is equal to 2. So you get the point 2, 0. All right. Now, the next thing is you find the y-intercept. And remember this one, you replace the x with 0, and you find the y. Same equation, 3x plus 2y equal to 6. 3 times 0 plus 2y equals 6. 3 times 0, that's just 0, plus 2y is equal to 6. That means that you have 2y equals 6. You divide by 2, gets rid of the 2, and so y is equal to 3. And so that gives us the point 0, 3. So you have 2 points now that you can use to graph the line, right? So let's do that. And so the graph is going to be, it's going to look like something like this. Okay, the y-axis, the x-axis, and you get the point 2, 0, so you get 1, 2, and then 0, so it's 2, 0, 2 comma 0, and then 0 comma 3, so 0 and then 3 there. And then you connect the 2 points and you extend the line, right? And that gives you the graph for 3x. This is 3x plus 2y equal to 6, the line. Okay? There it is. All right. Let me see. So we completed. I want to talk about 2 lines. Consider y equals -3 and x equals 2. If I were to graph these 2 lines, let me show you what they look like. And then we're gonna talk about some facts about these 2 lines. Okay, so if I graph x equals, first let me graph y equals -3. So y equals -3, you find -3 on the y-axis, so here we have, and it's just going to be a horizontal line at -3. So this is y equals -3. And then x equals 2, you find, let me just draw this right, x equals 2, you find x equals 2, here it is, and it's going to be a vertical line at x equals 2. So this is x equals 2. So notice that y equals -3 has only a y-intercept, right? This one, because that's where it crosses the y-axis. So the y-intercept is the point where the graph crosses the y-axis. So this is the y-intercept. So it has a y-intercept, and the y-intercept is 0, comma -3. But there is no x-intercept because nowhere does the graph cross the x-axis. Okay? And so here, when you look at x equals 2, it only has an x-intercept because it crosses the x-axis at 2, comma 0. So the x-intercept is the point 2, comma 0, and there is no y-intercept. Okay, so I wanted to show you these 2. Let me lower the paper a little bit so you can see everything here. So consider the lines y equals -3, x equals 2. The graph of y equals -3 is a horizontal line at y equals -3. The graph of x equals 2 is a vertical line at x equals 2. Y equals -3 does have a y-intercept because the graph crosses the y-axis at 0, comma -3, right here. So this is the point 0, comma -3. That's the y-intercept. But no x-intercept because nowhere does the graph cross the x-axis, right? So now here on x equals 2, the graph crosses the x-axis at the point 2, comma 0. Therefore, the x-intercept is the point 2, comma 0. But there's no y-intercept because nowhere does the graph cross the y-axis. Okay? So that is, I think, the last thing I wanted to talk about. So we've covered sections 2.7, 3.1, and 3.2. I'm going to make a different video for sections 3.3 and 3.4 so that the videos are not too long, okay? And we are already at 34.25 minutes, so I'm going to stop here. And so I will make the next video after this one. So stay tuned. Thank you guys. God bless. Bye-bye.